My name is Tim Farley, and I am a principal security consultant with Optiv, and I test web apps. And today my topic is talking about how to test that a web app is sending email as securely as possible. We're going to cover email sent by web apps, how this is done, how SMTP actually works, what the other sorts of protocols are that have been added over the years to make SMTP better, how insecure DNS ties into all this, and what the testing challenges are. If you're an application tester, either a consultant or a QA person testing an application, what are the challenges in testing this functionality? And there's actually a special case I'm going to cover of apps that don't send email at all. There's actually some email related configuration items that even a domain that does not send email should have in its DNS. I'll show you some testing tools and I'll give you some further reading to learn more about this. So email in web apps, very, very common. We've seen that most web apps have some sort of a way to confirm a person's identity using an email or tie their account to an email address. And a lot of times that's used for simple password resets. So this is all functionality that if you're testing the web app, you'd really want to test. And that testing should include the actual sending of the email. Is the email being sent in a way that's secure, or at least as secure as possible? There are also web apps that receive email. This is less common. We're not going to dive deep into that because I only have 30 minutes here, but this is a case that you should be aware of. Now, obviously, the threat model for email, there's all sorts of foolishness that can go on with email. So these are all things that you need to deal with. And when building a web app that sends emails, you need to be careful about how you configure that to minimize the chances of any of these things happening. So how does email get sent on the internet? It's with SMTP. And the S, of course, stands for simple. And it really is a very simple protocol fundamentally. You look up the DNS MX record, mail exchanger, it's a special record type, for the domain of the target address. You connect to port 25 on the IP address that's associated with that name. And then you issue some commands. You issue them as text. You can literally telnet to port 25 and engage in a perfectly valid SMTP transaction. This is what the actual transfers look like. And as you can see, this is a Wireshark capture, and you can actually see mail from, receipt to. The actual body of the email comes along with a bunch of headers. And these are very much like the headers you see in HTTP transfers, same sort of syntax, name, colon, value pairs. And some of them are very common things, from, to, date, subject, but a lot of them are much more arcane things that have to do with how the email was sent, what it refers to, whether it was checked for malware. There are standardized ones and there are proprietary ones. There's a number of problems with SMTP. SMTP is a really old protocol. It dates from 1982. It actually predates DNS. But it's the plain text nature means it can be snooped. The DNS system, when it finally came around, had MX records to identify who's supposed to receive email for a given domain. But there's no DNS record, or there wasn't at that time, to say who was the authorized sender. Now, back in the early days of the internet, most cases, those would probably have been the same server because people had simple configurations. But that is almost never the case these days. So there's a number of problems with SMTP. As is true of HTTP and browsers and stuff, things were added piecemeal to the specifications as needed, as problems were identified. Literally, there are hundreds of RFCs that relate to email in one respect or another. Here's a sampling with the years they were adopted of various specifications that relate to securing email or encrypting email. And as you can see, it's been years and years of this stuff, and it's continuing up until the present day. So each one of these deals with a very specific thing. Not all of them, a few of them actually alter the SMTP protocol, but by and large, a lot of these solutions happen outside of SMTP. They happen out in DNS. The very first thing that was added to SMTP related to security is opportunistic TLS. It is literally a command in the protocol, start TLS. Unlike HTTP, where you connect to a different port and do the TLS negotiation right up front before you do any HTTP transactions, SMTP uses a single port, port 25, and you optionally switch to TLS using a command. And in fact, the specification says that you're not supposed to require the use of start TLS because it's considered a virtue that email can be sent unencrypted. But here's what one of those connections look like. You can see that in this case, just two commands were issued, hello, there's always a hello command at the top, and then start TLS. And then this is also a Wireshark capture, so you can see the protocol on the left is SMTP at the start, but as soon as it gets into the TLS negotiation, it turns into TLS version 1.2. And after the encryption handshake, everything's encrypted on the connection. The problem with this is, what if I can man in the middle your connection? I can get in the middle, or if I can tamper with just a few of the packets, I can stop that start TLS command from actually happening and cause the connection to downgrade into a plain text connection. And because the specification says that your server has to support plain text emails, it will work in most cases. So that can essentially strip the TLS off your email connections and let people snoop your email. And unless you're digging around deep in your email logs, you might not ever know that this was happening. Now, remember back when I was talking about MX records, part of the problem these days is who's entitled to send email for my domain. That might be the MX record, but it might be somebody else. That's where sender policy framework comes into effect. And for whatever reasons, they use a text record in DNS attached to your domain. And there's a parsable sort of language that's in that that allows you all sorts of flexibility in terms of including different domains, including IP addresses. You can specify IP version 6 addresses. You can say my MX server is allowed to send email for me, and so on and so forth. And so there's a lot of opportunity to be very flexible here, but there's also a lot of opportunity to shoot yourself in the foot if you're not careful. And it's somewhat straightforward to accidentally write an SPF record that will cause all your email to go into the bit bucket. So you have to be careful about configuring this. That solves the origin problem of, is this IP legitimately entitled to be sending this email? What about the tampering problem and the non-repudiation problem? Well, that's where DKIM comes in. DKIM is a way of signing the headers of an email so that you know that it was signed using a key that's associated with a particular domain and that it hasn't been tampered with since it was signed. And the DKIM keys are actually also stored in DNS, also using DNS text records. Now, there were still, as I said, lather, rinse, repeat. After they did SPF and DKIM, there were still some subtleties in implementing the two of them. Like, for instance, if the SPF check passes, but the DKIM check fails, what should the receiving server do? Or vice versa. And if one of these things fails, should I report that to somebody? Wouldn't you like to know that if you did put a DKIM signature on your email and I check it and it fails, is there some way you can get a report back on that? That's among the things that DMARC solves. There's a lot to DMARC. It also uses a DNS text record. It also has a parsable string that you can put in there. So you have a lot of flexibility to configure all sorts of different rules and say, I want to be strict about this. I want to be lax about that. I want my reports to go here. For all three of those are designed. One of the reasons they use DNS is those checks can be done very quickly at the time that the email is being received in the server. So it can make a very quick yes, no decision. Is this spam? But the problem is that that decision gets made, and then potentially, depending on how your server is configured, the results of the decision are just acted upon and thrown away. So you might want to know what that decision was after the fact. So there's an RFC for that. That's the authentication results header, which is a type of header that can be appended onto an email. As emails get forwarded, that list of headers gets longer and longer and longer as it moves through the system. And authentication results is one of those headers, and it's a series of name value pairs along with comments. The stuff that you see in parentheses there are comments. So if you wanted to go back and say, hey, what was the status of this email when it was received? This is very useful when you're testing applications, because a lot of times this is the only thing you're going to have. This is what's going to be in your inbox, and you can look at it and determine whether or not there's something you should dig in. A few up and coming standards that aren't widely deployed yet. MTA-STS is literally the equivalent of HSTS in HTTP, but for SMTP, it's a way of your server announcing to the world that it would prefer that everybody use Start TLS. And there's a reporting functionality that goes with it. ARC is a standard to send those authentication results headers in a way where they are cryptographically signed. So if they have to transit between servers, you can have some faith that they have not been tampered with. Require TLS is a way on an individual email basis to flag emails as being sensitive or not sensitive, such that they should be always sent using TLS. So for instance, if you're sending an email using TLS, you can flag it in the actual SMTP protocol, and the server that receives the email, if it needs to forward it somewhere else, should use TLS. And you can flag non-sensitive emails to the reverse of that. BIMI is a user-targeted thing, unlike the rest of these that are targeted at professionals and server administrators. BIMI is targeted at the end user, and the idea is that if all the security checks check out, it will put a company logo next to corporately generated emails in a secure way, so that if you see that logo there, you know that email has been checked. And it's the first time any of these specifications have really thought about how should this be presented to the end user. But it's still being worked on. It doesn't even have an RFC number. So if you've been paying attention, you've heard DNS many, many times in this presentation, and you may be wondering, well, what about attacks on DNS? What about DNS cache poisoning? Can I undermine all this stuff simply by fiddling around in DNS? And that's true. And that's why if you talk to folks at IETF and people who are really serious about email security, they'll tell you that if you want your email to be secure, you should be doing DNSSEC. Because of course, even those MX records, if you're not sure the MX record actually came from the original host, then your email could get diverted to another server. The problem with DNSSEC is that it isn't widely supported. The major providers and the top level servers support it, Google, Cloudflare, and so on. But a lot of the measurements I've seen say that only 25% of the internet is actually doing DNSSEC. People are very wary of it. It's easy to misconfigure it. And that's too bad, because there's a specification specifically related to email called DANE that allows you to essentially do kind of a certificate pinning thing so that you can prevent somebody from doing a man in the middle with a fake certificate on your email connection. But because people haven't adopted DNSSEC, people haven't adopted DANE, and that's actually why MTA-STS was created. So if your app is targeting a vertical that uses DNSSEC, then I would say yes, the email server should use DNSSEC, but most end user commercial sorts of apps aren't going to support that. So if you are testing, what are some of the challenges you're going to have? Well, one of the problems is you don't really always have control in a test scenario of your target email address, right? Some apps will let you send emails to arbitrary addresses, but some apps will only send emails to the account email, and that may have been provisioned for you ahead of time. And you may not have a lot of control over it. You may be testing in a test environment where email is not enabled. That's going to stop you right there. The biggest problem is email goes somewhere else, right? If you're testing a web app, you're using an HTTP-based tool, and you're looking at traffic going back and forth between your browser and the web app. The email is happening somewhere else entirely between some email servers. Now, it's happening on the internet out where you potentially can get a look at it, but you need to use other tools. Now, that may ring a bell for you if you've used Burp, because Burp has this thing called Collaborator, right? It is an attractive option for testing email, but it has some pros and cons. It does implement a port 25. If you write an extension to Burp, you can actually get access to everything that's happening on those connections. So you can actually see what the email transfer actually looked like. But there's a lot of negatives. You don't have control over that SMTP server. So for instance, you can't make that SMTP server reject the start TLS command to see what the other side does. And then, of course, there's all these DNS entries that have to be configured outside of SMTP entirely. You'd have to set up your own Burp collaborator, which you can do in order to control those. But the big problem with Collaborator is Collaborator uses ephemeral addresses deliberately so that you can prove that the testing that you did really was related to the transfer that you saw. And the problem is those go away, right? So if the app is going to send email overnight, for instance, to you, you may have closed your Burp session before the email actually gets sent. The app may not let you specify a collaborator email address. So it's not really super useful in all situations. But it is useful in a few. So I'm going to demonstrate that a little bit here. Obviously, a lot of this stuff is in DNS. So you can use whatever tool you are familiar with, but I'm going to use Dig. Like I said, a lot of these things are text records. So if you can dig the text record off of optiv.com, you see that text records are used for a lot of different things beyond what we're using, but down in there, you can see the SPF record. So we can grep that out so it stands out. And there it is. There's Optiv's SPF record that you saw on a slide earlier. And it's very similar for the other sorts of things. Every one of these specs has its own little special place in the DNS infrastructure that it puts these records. And I wrote a bash script that actually, you hand it a domain name and it looks for these different things, the sender ID config, the domain key, there's a spec called ADSP, here's the MTA STS. So let's do that for someone we know configures a lot of this stuff, which is Gmail. And you can see that Gmail has SPF configured, DMARC configured, and the other two. You can actually test whether Dane is working. I wanted Comcast.net. Okay, you can see Comcast.net right there actually has a Dane configuration. And the Dane records are another type entirely, TLSA record. And they're rather cryptic. That's a signature of a certificate. I wrote a very simple, I haven't released it yet, but it's a very, very simple Burp extension. It's only a couple pages long that just does the very basics of an email transfer. And it's called email security here. And I just click this to load it into Burp. And when it loads, it spits out an email address right here at Burp Collaborator. And over in another window that you cannot see, I am going to send an email to that address and it will transfer across. You have to wait for a second because, of course, email infrastructure takes some time to relay things, to virus check things, to pass them along. And then, of course, the collaborator is polled periodically. So, and there we go. You actually get a text item back in the collaborator that you can access via the API. That's the entire conversation that happened on the SMTP. But just using some regular expressions, I pulled out that there's a DKIM header, here's the IP address it was sent, and then I called an API to check the SPF record. So you can actually get some basic, if you can convince the web app to send to one of those funky burp collaborator addresses, you can actually get some interesting results. But more likely, you're going to end up having to deal with email headers. So you're going to end up looking at text like this, right? This is an email this is a marketing email that I received from Sneak. And as you can see, there's hundreds and hundreds of headers in here. Right here in the middle is the actual headers of the email that you recognize as an end user. All the rest of this stuff gets hidden by your email client. And generally speaking, the original email is down at the bottom. And as emails get forwarded, things get added to the top. That's not always 100% true. There are email servers that will reorder some of these headers. So you have to be aware and you have to be careful about interpreting the order of these headers, but many of them have date stamps in them. So for instance, this email was sent with DKIM, and you can see that it actually has two different DKIM signatures, one from marketomail.com and one from sneak.io, because the email appears to be from someone at Sneak, but was actually sent by Marketo. So they sign it with both for an extra level of security. And then you'll see that there are these headers that say received, and this particular email has a whole bunch of them. So it was forwarded several times because we use Proofpoint, and Proofpoint acts as an email server out in front of your server. It went through a couple of Proofpoint servers before it got to our server, and then our server forwarded it a few times before it eventually got to my email box. So if I was just looking for authentication results, I would find this yellow one here that shows me a lot of failures. And that's not encouraging. Why is this thing failing? Well, this is actually an authentication results from when the email jumped from Proofpoint to Microsoft, and therefore is not that useful because it doesn't really reflect when the email came in off the internet. Proofpoint moves the original authentication results header to authentication results original, at least in our config. So that's the one, at least inside Optiv, that you want to look for, okay? This is going to vary. It's going to depend on how your email is configured. So you need to learn what a good email looks like on your server. And then when you test an application, you'll be able to know what's good and what's bad. Now, there's one other scenario that nobody ever thinks about, which is, what if my application doesn't send email? Well, why would I need to configure email stuff if I'm not sending email? Well, the problem is phishers. Okay, if you have a domain out there and it does not have an SPF record and it does not have a DMARC record, a phisher can potentially use your domain to send email. Now, they may end up in the spam folder on many targets, but they may not. And you would have no way of knowing that was going on. You might get some bounce messages maybe, but a lot of email servers have disabled bounce messages. So there are versions of these configuration items in DNS that you can set up essentially a negative SPF, DKIM, and DMARC configuration for your server. So you may want to send the emails to some other domain. In order to do that safely, there's a fourth record you need to set up, and it needs to be set up in the other domain that essentially says, yes, it's okay to send DMARC emails for example.com to tellme.com. And if you want to see an example of this in the field, look up the DMARC record for altavista.com. If you have an application that doesn't send emails from its own domain, you should have these three, possibly four records setting in there. So how do you get those email headers? A couple little, most of you probably know how to do this, but just a couple little reminders. If you're using Outlook, it's different in Windows and Mac. On the Windows side, you have to open the email and do file properties, and you only get the headers. On the Mac side, you have to click on the email in the list. Don't open the email, but click on it in the list and do view source. And on the Mac side, you get not only the headers, but you get the body of the email in its raw form, which is useful for certain types of things. If you have switched to the quote unquote new Outlook that they recently deployed, if this functionality still exists in there, they have hidden it well enough that I can't find it. Over on the Gmail side, I'm not going to go through every email client, but Gmail is significant because so many people use it. It's in the little ... menu in the upper right of an email. You click Show Original, and you get this really nice display that has not only the headers and the body in raw form down at the bottom, but it has this nice, simple interpretation of the SPF, DKIM, and DMARC. You can see right there in the middle above my head that this particular email was pass. But if you see fail or soft fail there, or if any of those three lines is not present, like if there's no DMARC line, that is a red flag that you should possibly be dealing with. Now, like I said, a lot of those configuration items in those DNS text records are essentially a little tiny language. And like any language, you can mess them up. So there are web-based testing tools that will interpret the contents of those fields and give you a detailed list of what you got right and what you got wrong. One of them is MX Toolbox, which is oriented toward people who administrate email servers, hence the MX. And this is their SPF display, and you can see it breaks your SPF record down, and it shows you each entry and whether or not it's correct, and it gives you a bunch of green check marks. So this is a good way of finding perhaps syntax errors or inadvisable configuration choices that you could ding the application owner on. Another one is called Hardenized that checks a whole bunch of things all at once. You just give it a domain name and it'll check whether DNSSEC, whether DANE is configured, MTA-STS, TLS report, and it'll give you a similar detailed listing of your SPF policy. A number of resources I can recommend for further reading and further research. If you want to find other tools that suit your way of working better, or maybe you want to write your own scripts and you're looking for a library in Ruby to do SPF, these things all exist. All these standards have been around long enough that there are libraries in almost every programming language to handle this stuff. And you can go to the organization sites for SPF, DKIM, and DMARC. And then there's two documents that I highly recommend. One is the NIST document, Trustworthy Email, which is 115 pages, but it's a really good read and really well explains how these standards fit together, how you should configure them on your servers, why you should configure them that way. And it's designed for an administrator of an email server to go through step by step and figure out what they need to fix. On the attack side, there was a paper presented at Usenix last August that has to do with bypassing DKIM checks. And it has some interesting advice for how you should configure your DKIM. And in particular, that paper is good because the references have a number of references to the relevant specifications, but also to some really good blog posts of prior work in email spoofing, email phishing, how to get around these specifications. And, of course, in order to harden up your configuration of your email server, you need to know what the attackers are doing. So we can do some questions and answers. I am at Krelnik, Krelnik on Discord and on Twitter. And I hope that was helpful to you.